Myself, Swapna V. Shashi, Assistant Professor, Department of CSE, Jyoti Engineering College. I am going to take various topics in compiler design. Next topic is intermediate code generation. In compiler, the front end translates a source program into an intermediate representation from which the backend generates target code. So, input of compiler will be a source program, output will be a target code. Intermediate code generation process should not be very complex. It should not be difficult to produce the target program from the intermediate code. A machine-independent code optimizer can be applied to the intermediate representation. Various intermediate languages used for representing intermediate code are syntax tree, directed acyclic graph, postfix notation, three-address code. So these are the various forms of representing intermediate code. First one is syntax tree or abstract syntax tree. It is a graphical representation. Syntax tree depicts the hierarchical structure of a source program. It is a condensed form of parse tree which is useful for representing language construct. A parse tree and syntax tree for the expression 3 into 5 plus 4. The given grammar is E2 E plus T, E2 E minus T, E2 T, T2 T into F, T2 F and F2 digit. Corresponding parse tree will be E2 E plus T, E2 T, then T2 T into F, T2 F, F2 digit, digit to 3. Here the yield of the parse tree will be 3 into 5 plus 4. Corresponding syntax tree will be plus then star 3 into 5, that is 3 into 5 plus 4. So syntax tree is a condensed form of parse tree. In the case of parse tree, how the production rules are applied, this will be depicted. Whereas in the case of syntax tree, only the operands, operators and operands will be shown. So, differences between a parse tree and syntax tree. Parse tree is a graphical representation of a replacement process in a derivation, how the productions are applied. In the case of syntax tree, it is a condensed form of parse tree. In parse tree, each interior node represents a grammar rule. In the case of syntax tree, each interior node represents an operator. Each interior node represents an operator in the case of syntax tree. Each leaf node represents a terminal in the case of parse tree, whereas in the case of syntax tree, each leaf node represents an operand. Each leaf node represents an operand in the case of syntax tree. Parse tree represents every detail from the real syntax, whereas syntax tree doesn't represent every detail from the real syntax. Example, no parenthesis will be shown in the case of syntax tree. How the syntax tree can be constructed? These are the functions used for creating a syntax tree. mk node, mk leaf. If it is an identifier or variable, this function can be called mk leaf of identifier comma entry. Entry means what value will be entered into the symbol table for the variable id. Then mk leaf of num comma value. If the leaf is a digit or a number, then the value of the number or digit will be returned from the function mk leaf of num comma val. So this function creates an identifier node, whereas this function creates a number node. Then mk node of operator comma left comma right. This function creates an operator node with label op and two fields containing pointers to left and right. So All these functions return a pointer to a newly created node. For example, a minus 4 plus c. The tree is constructed bottom up. That is, first leaves are constructed mk leaf of id comma entry a. First a node is created. How the a node is created? A is an identifier. For that mk leaf of id comma entry. So a will be returned to p1. Then mk leaf of num comma 4 for creating node 4. We are using mk leaf of num comma 4. That will be returned to p2, pointer 2. Then p3. p3 consists of a, it consists of an operator. Then left pointer will be p1, right pointer will be p2. That is minus, then left pointer, right pointer. Similarly, p4 and p5. Then the corresponding syntax tree can be created. So initially the leaves will be created. Then the interior node will be created by calling various functions.